Hello everyone, myself Dr. Sunil Kumar from L&T College Muzaffarpur. Warm welcome to L&T College Multimedia Studio Muzaffarpur. Today I have brought a more interesting and exciting topic in chemistry, that is the nitride and carbide of alkaline earth metals. So the chemistry behind these topics involves a fancy and interesting uh, type of bonds and their properties. So this topic is actually only for the alkaline earth metals, not then other than these metals, right? So as in the previous lecture we have defined and studies about the alkaline earth metals, that is beryllium, magnesium, calcium, strontium and barium. So these are the alkaline earth metals. Since our topic and title is based on nitrides, right? So first we will define what is nitride, right? So as you know that our environment or atmosphere consisted of nitrogen gas, right? So this nitrogen gas has a chemical formula, that is N2, and if we draw the structure of this particular molecule, so it contains N triple bond N, right? So this is the structural formula of this N2 molecule, and which contains 3 bonds. So that is covalent bonds, and these 3 bonds actually 1 sigma bond, right? 1 sigma bond and 2 pi bonds, right? So because of the share of the electrons between 2 nitrogen centers, they form stable molecules, and each nitrogen follows the octet rule, and hence they are most stable, right? Most stable, or you can simply say the nitrogen molecule is actually environmentally stable at ambient temperature in the atmosphere, right? So it is treated as inert molecule, and they are not actually reactive. So the reactivity actually can be produced in this molecule through the polarization effect, right? So once this particular nitrogen gas react with alkaline earth metals, so that is actually beryllium and magnesium and calcium and strontium and barium, they produce M3N2 type of structure, right? So one nitrogen molecule actually contains 3 metallic constituent. Here the formula, that is M3N2. So this M3N2 N2, actually this M stands for M2 plus. In case of M2 plus, so that is here beryllium 2 plus, or it may be magnesium 2 plus, or it may be calcium 2 plus, and similarly strontium 2 plus and barium 2 plus, right? So as you know that all the alkaline earth metals actually they contains 2 positive charge, right, after ionization, hence it is called bivalent electropositive metal cations. So all the alkaline earth metals, they are actually bivalent electropositive metals or electropositive cations, right? So because of the sufficient electropositivity, So they have tendency to attract negatively charged species or negatively charged anions to form a particular compounds, right? So what happens actually here, once alkaline earth metal, right, either beryllium or magnesium or calcium, they can react at high temperature in the presence of nitrogen, right, to form M3N2 type of compounds. So this compound is actually ionic, hence you can say that once the alkaline earth metal forms a compound that is M3N2, right, so this compound is ionic, not 100% ionic, rather it is a it contains also a degree of covalency because of the covalent bond in this particular structure or because of the polarization effect. So in this particular type of structure, actually M consisted of, that is 2 plus, that is bivalent cation, and this N2 is actually converted into N3 minus, right? So here 3M, since here 3M, right, here we have to multiply 2 and 3 minus, and then it can forms M3N2, right? M2 plus will be balanced by 3 mole, and nitrogen is balanced by 2, then it forms M3N2, right? So because of presence of 2 positive charge on this particular metal and 3 negative charge on this particular pristine nitrogen, right? So this is N3 minus, this is called nitride, right? So this is what is nitride. It means nitride is actually obtained through the dissociation of the nitrogen molecule, right? And how dissociation takes place in this particular stable nitrogen molecule, that we will focus and illustrate the ideas regarding that. So what happens actually, as you know that this nitrogen, that is N triple bond N, so it has actually very high dissociation energy, right? So high dissociation energy means the energy required to break down these 3 bonds is actually very high. So that is approximately or around, that is 945 kilojoule per mole, right? So this is a huge amount, so that is actually required to break down these particular 3 bonds. So that is why this nitrogen, that is N2 gaseous molecule, actually it is unreactive or it is inert. So how the reactivity comes in this particular nitrogen molecule, actually it comes from lattice energy, right? So lattice energy, right? As in the previous lectures, we have defined very clearly about the lattice energy. Actually they are related to the ionic solids. So here in case of nitrides, actually all the alkaline earth metals form nitrides. So how the lattice energy is correlated with this particular nitrides. Here suppose we have Mg3 and 2. So this is a magnesium nitride. It means 2 nitrogen atoms and 3 magnesium atom, after combination they form a particular type of compound, so that is ionic in nature, right? So this is ionic compounds, and this is a solid, and it is a very tough and hard compounds. It melts at high temperature. So this magnesium nitride actually contains Mg2 plus, and this N2 is converted into N3 minus. So this is your magnesium bivalent cation, and this is 3 negatively charged nitrogen, that is nitride ion. And this nitride ion actually contains total number of electron, that is 10 electron, right? This is total electrons, that is 10 electrons, and 10 electrons is equivalent to the electronic structure of the neon, right? So neon is a noble gas which is inert at room temperature, right? So this nitride ion has a valence electron, right? Valence electron, that is 2, 5, that is actually it's 2 and 5. This is the electronic configuration. You can simply say this is the general electronic configuration, plus we can add 3 electrons, right? So overall 2, 8. It means the valence shell is completely filled with 8 electrons. So that follows the octet rule, right? So this particular negatively charged species actually form a ionic compound with highly charged bivalent cations, right? So this is the beauty actually. Mg2 plus, and that is N3 minus. As you know that from the Born-Lande equations, which is used to calculate the lattice energy of ionic solids, is actually depends on U is depends on Z plus and Z minus. This is the product of charges on cation and anions of the particular ionic solids, right? And what is the actually interionic distance? That is simply you can say that is your R0. So after the formation of that particular type of ionic compounds, they possess a fixed interionic distance. So this is your R0, and here the product of charges actually, this is your 2 and this is your 3, right? So overall this is your minus 6, it means 6, right? So the lattice energy U is 6 times of the first group alkali metal nitrides. In the group first alkali metal chemistry, as you know that lithium is the only metal that forms nitride. Like suppose this is your lithium solid metal, once they react at high temperature with the nitrogen, they forms Li3N, right? So this is trilithium mononitride compounds, which contains actually Li plus, right, and N3 minus. So here the lattice energy actually is due to the contribution of +1 charge and -3 charge, right? So what ultimately it gives, that is 3 times, right? Here it is 6 times. So the lattice energy of group first alkali metal nitrides actually has actually 3 times of the charges and 6 times of the charges for the alkaline earth metals. So which one will be most stable and high lattice energy? So naturally you can say through this particular calculations that the alkaline earth metals Mg3 and 2, they are more stable as compared to Li3N, right? So this is your lithium nitride and this is your magnesium nitride. So because of the high lattice energy or sufficient lattice energy, these compounds are highly stable and it has very high melting point and very tough materials. So they can be used for the various purpose at a industrial scale or at a commercial scale, right? So because of the high charge density 2 plus and this is high charge density that is 3 minus, so there is a high electrostatic interaction between these two ions that will produce more negative lattice energy, and that lattice energy actually polarize this nitrogen molecule, right? And after the polarization of nitrogen molecule, it will be converted into nitride ion, that is N3 minus, right? So what happens here, because of the polarization effect of or polarizing power of this particular metal bivalent, the nitrogen molecule does not remain as a nitrogen molecule, rather it is dissociated or converted back into N3 minus, that is nitride ion, right? So it has very high lattice energy and the dissociation actually is obtained through this particular type of lattice energy, right? So what happens, all the alkaline earth metals actually forms nitride compounds, right? So because of the reactivity of nitrogen gas at a particular temperature, they all forms M3N2 type of ionic compounds. So what is the actually how they are actually formed? So here in case of that is actually beryllium nitride, that is Be3N2, Be2 plus as highly charged and a small species that will polarize the nitrogen or nitride electronic structure because of the formation of high covalency character in this particular compounds. So this particular compounds actually because of high polarization are covalent characters, and actually they are very hard. It melts at by 22 hundreds degrees centigrade. So it has very high melting point. It means the compound, although it is a covalent, but it is a hard and tough ionic compounds, right? So similarly, magnesium directly react with nitrogen at high temperature to form magnesium nitride. It has a greenish yellow color, right? So Mg3N2 possesses greenish yellow colors, right? So this is a type of the beauty of the particular nitride. And in case of that is your calcium, so calcium, that is 3 volume of calcium will react with 1 volume of nitrogen to form a similar structure, that is calcium 3N2, that is calcium nitride. And here also it contains that is N3 minus, right? So what is the property of such type of nitride compounds? So that will be highlighted through this particular type of reactions, right? So here we have shown very clearly that calcium nitride would react with water, or simply you can say this particular calcium nitride actually react at with water, undergo rapid or vigorous hydrolysis to produce a gas, that is inorganic gas, that is ammonia gas, that is NH3. So this is your ammonia gas. So in a conclusion or in a simple words, you can clearly dictate here, once the nitride compounds they react vigorously with water at a high temperature to produce ammonia gas. So this is the source of ammonia gas productions. So nitride compounds are actually source of the production of ammonia gas. Here calcium nitride would react with 6H2O, and it requires how volume, that is 6H2O, right? So 6H2O at high temperature, they will produce calcium hydroxide, that is CaOH ka whole twice. So this is your insoluble hydroxide and ammonia gas that is liberated in this particular reaction. So this is the most important reactions for the production of the ammonia gas at a industry level. Now the next reaction follows similar type of reactions. So that is actually calcium nitride once react with hydrogen gas at high temperature, that is 400 degrees centigrade, they will produce calcium amide type of structure, followed by liberation of the calcium hydride. So this calcium hydride actually works as a hydrogen energy storage materials. So this is the actually importance of this particular type of calcium nitrides actually that is used to produce the ammonia gas and hydrogen storage materials, that is calcium hydride. So as a from the point of view of research, actually that is the most important reactions. So that is used to produce ammonia gas as well as calcium hydride, right? So all the actually alkaline earth metal, they form like this type of structure, that is M3N2, and their lattice energy and their stability depends on actually the energy. So that is lattice energy which will stabilize the lattice structure, right? So next, so this is actually related to the chemistry of alkaline earth metals. Okay, so now we come across carbides. So in this particular section, actually in case of carbides, carbides means here is a role of carbon, right? So this carbon actually has electronic configuration, that is 1s2, 2s2 and 2p2, right? So it has 4 valence electron, right? 4 valence electron, and if 4 valence electron is shared, then it forms actually a covalent bond and follows the octet rule. So this carbon has actually 4 valence electron. So this carbon can exist as anionic species, that is C4 minus, right? So this is your carbide, or you simply say because of the one carbon atom, so they are called methanide ion. So this is your methanide ion. In a simply we can say this is a carbide ion, C4 minus. So what is carbide actually? So carbides are actually materials, so which can be classified actually ionic, salt like and covalent and interstitial or alloy based carbide materials. So ionic carbides actually form through electropositive metals, and it is a binary compounds, right? So which forms a salt like structure with group first and group second metals. So they are actually carbides. Covalent carbides, it means there is a sufficient covalent character in this particular carbides. They form through the combination of the two different non-metals. Here are metallides in case of that is S3 and 4, SiC, that is silicon carbide, this is boron carbide, this is sulfur nitride, right? So these are the carbides which possess a network of covalent bonds as a expanded surface. And third one is the interstitial, that is Li based carbides, where carbide ion actually exists as in the lattice structure to balance the another metals. Right, so this they are very tough and hard, that is tungsten carbide, and this is your titanium nitride. They are the example of interstitial or Li based um, carbides. So why such type of advanced chemistry is interesting here? So because of the application of the product based on the carbides. So in case of carbides, as you know that some hard or tough tools, so that can be cut with the help of the carbides, or simply you can say it is used as a cutting materials, or it is used as a cutter for the hard materials. And in simply you can also dictate here is that these type of compounds actually used for other purposes in the chemistry, right? So these are the actually carbides, that is ionic carbides. So because of the formation of the ionic bond between cations and anions of a particular species. And next one is the covalent carbides, and it actually forms through the sharing of the electrons between two different atoms to form a particular covalent bond. So it is called covalent carbides. And this is interstitial, and because of the stability of the lattice structure between metal and non-metals in a Li state, so that is called tungsten carbide or titanium carbide, right? So here we are interested to focus on the chemistry of alkaline earth metal which forms carbide structures, right? So this particular carbides actually are different types. They actually contains either C4 minus charge or C2 2 minus charge or C3 4 minus charge, right? So actually depending on the nature of the another participating metal or non-metals, they form particular ionic species, that is monocarbon which contains 4 negative charge. So this is actually called methanide ion. Because of the presence of one carbon atom, they are treated as methanide ion, because this methanide ion C4 minus is derived from CH4, that is hydrocarbon, which is referred to as methane. So simple carbide ion is a result from the deprotonation or all deprotonation of the hydrogen from this particular compounds, then it forms C negative 4 charge. And similarly, this is your C22 minus because of the 2 carbon atom. So this is actually this contains a structure like that. This is your C bond C, so that is your triple bond. Here you can simply say this is your 2 negative charge, and equally these 2 negative charge will be distributed or localized over these two particular centers, that is C minus and this C minus, which completes the octet rules, right? So C2 2 minus here 2 negative charge is a also type of carbide species. So this is called acetylide, and acetylide carbide ions, or it is actually acetylide, right? Because of the formation of the acetylene gas. This is CH triple bond CH, right? So this is acetylene gas, and this acetylene gas, after deprotonation of both hydrogen, they form C triple bond C overall 2 negative charge, that is also type of carbide species. and third one is actually C3 4 minus. So here C3 4 minus, actually how it is formed. Here it is C, that is your C, and 4 negative charge. It means here 1 negative charge and here 3 negative charge, right? So overall you can say that C triple bond C, here is 4 negative charge. So this is actually combination of 3 carbon centers. So one carbon centers occupies 3 negative charge and another end carbon occupies 1 negative charge. It means ki it is derived from CH3 C triple bond CH, right? So this is your propine, right? Is nothing but this is a hydrocarbon, is called propine, and after the removal or deprotonation of all the hydrogens from this particular structure, then we can get this particular type of species that is called alkylide ions. So this is actually alkylides, that is C3 4 minus, right? So these are the 3 carbon which is a anionic species. They form a different compounds with a particular combination of the metals, right? So here I have shown that how a particular carbide compounds are formed, right? So here we have given the ideas of the synthesis or preparation of a particular carbides. So in case of that is actually alkaline earth metals, the first element is that is beryllium, right? So if I think how beryllium carbide is produced, then actually it is produced through the reaction at high temperature. So it requires high temperature. So this is beryllium oxide, which is covalent compound, would react with this carbon, or in simply you can say in an electric furnace with a carbon at high temperature, that is 19 to 200 degrees centigrade. So this forms ultimately a brick red compounds. So that is Be2C, right? So this Be2C contains C4 minus, that is carbide ion. So beryllium carbide, which is a brick red compound, right? So what is the beauty of this particular carbide? So Be2C, that is beryllium carbide, undergo rapid or vigorous hydrolysis in the presence of water. So ultimately it forms beryllium hydroxide, that is 2 volume of beryllium hydroxide and 1 volume of methane gas, right? So because of the production of the 1 carbon enabled gas, that is methane gas, and since this methane gas, after removal of all the hydrogens, it is converted into C4 minus, right? So it contains actually carbide ions, that is methanide ions. So what happens here? This particular type of carbide, that is actually beryllium carbide, requires a large amount of water, that is 4 volume. Through this particular reaction, you can see that is 4 volume of water required to create 2 volume of beryllium hydroxide and 1 volume of carbon, that is hydrocarbons, that is methane, right? So this is the actually beauty of production of the methane gas. So in the organic chemistry, so methane gas can be produced with the help of this particular carbide structure, right? So now suppose we want to prepare or synthesize another carbides based on the calcium, magnesium, or strontium, barium, or any other alkaline earth metals. So then we have to treat particular methods or temperature we have to follow. Suppose we want to synthesize or prepare calcium carbides, then what actually happens if we have a calcium, right? So this is calcium in a solid state compound and would react with 2 volume of or 2 mole of carbon powders at high temperature. Heat is at high temperature, that is 1100, right, degree centigrade. So it forms a structure that is MC2 type of structure. So in the previous reactions, actually that was based on C4 negative charge, that is methanide ion. Here this particular reactions, not only these reactions, so apart from the beryllium, right, so beryllium, all the metals, that is magnesium, calcium, strontium, that is barium, right. So all these alkaline earth metal, they react at high temperature in the presence of carbon. So they would produce such type of MC2 type of ionic compounds. So MC2 type of ionic compounds means this contains such type of compounds. So M, this is your 2 plus, and this C2 as a 2 minus. So this is a binary compounds actually, one, so a center, and this is your whole another center. So this is the combination of 2 species, so they are called binary compounds. And not only binary, it is a binary or inorganic or ionic compounds. So here what you observe, that is C2 2 minus. So 2 positive charge and 2 negative charge, they will electrostatically attract to each other to form such type of particular carbides, that is MC2. So this is your here what actually inferences are obtained from the particular calculation of the lattice energy. Here 2 multiply 2, that is 4 times, right. So here 4 times of charges, so it has actually very high lattice energy. So as comparison to the nitrides, and these carbides have little less lattice energy, because in case of alkaline earth metal nitrides, where the lattice energy was derived because of the contribution of the 6 time of the charges. But in case of this particular carbides, here lattice energy are particularly derived from the contribution of the product of the charges as 4 units. So naturally lattice energy of the alkaline earth metal carbides is little lower compared to the alkaline earth metal nitrides. So this is your M2 plus and C2 2 minus, and because of formation of this particular C2 2 minus, so it is derived from C triple bond C H, and this is H. So this is your acetylene gas. Yeah, simply you can say this is a ethane gas, a particular type of unsaturated hydrocarbons. So beryllium onwards, actually they are the source of the hydrocarbons. Actually in this particular reactions, they produce acetylene gas through the hydrolysis with the help of H2O. So after the removal or deprotonation of all the hydrogens, it produces C2 2 minus type of actually structure. So it is also it is called acetylide ion. So this is your acetylide ion. This acetylide ion actually contains 10 valence electrons, right? Total 10 valence electron among 2 carbon centers, right? So it is isoelectronic of the it is actually the valence electrons are isoelectronic to the neon, not helium here. So what are the actually properties of such type of carbides? So in this particular sphere you can see the calcium metal directly react with carbon in electric furnace at high temperature, so that produce calcium carbide. And similarly another way of preparation of the carbides follows, that is calcium oxide. So that calcium oxide would react with 3 volume or 3 mole of the carbons at high temperature, nearly 2000 degrees centigrade, that produce calcium carbide and carbon monoxide as a byproduct gas, right? So all the alkaline earth metal actually they forms MC2 type of ionic solids, so they are treated as ionic carbides. Now we come across the properties. So what are the properties of actually such type of particular ionic compounds? So from this particular reaction you can easily understand here the calcium carbide, so that is CaC2, once react with 2 volume of water. So here reaction takes place vigorously and it requires high temperature to produce, and then it forms calcium hydroxide as a insoluble compounds, followed by a release of this particular unsaturated hydrocarbons, that is acetylene gas. And this acetylene gas actually after deprotonation of the all hydrogens they contain C2 2- type of species. So in a simple words you can say alkaline earth metals beryllium onwards, they actually are the source of the production of the acetylene gas. In the previous reactions, that is in case of beryllium carbides, actually they are the source of the production of the 1 carbon hydrocarbons, that is methane. Here that is acetylene gas, and this acetylene gas is the most important gas that is flammable in nature, right? Either methane or acetylenes, they are flammable. Okay, so because of the production of the acetylene gas, so this is the most important reactions, and calcium carbides, that is actually most important inorganic ionic compounds or ionic carbides, so that is used to produce in a acetylene gas at a industrial levels, right? So what is the next properties of this particular type of ionic carbides? That is actually calcium carbide. So this is your calcium carbide, once react with nitrogen gas at high temperature, that is 1100 degrees centigrade, it forms calcium that is CaNCN, right? So this is cyanide ion. So calcium cyanide, that is your calcium cyanide, and this NCN has a structure like that, that is N double bond C double bond N overall 2 negative charge. So this is a isoelectronic, right? So this is your isoelectronic with CO2, right? So the number of total electrons in this particular ionic species are equivalent to the number of total electrons in this particular gaseous carbon dioxide. So this is the beauty of this particular species, and this forms also carbon as a solid powders, right? So this is what is the actually variation in a chemical reactions is actually used for the preparation of another precursors or other materials for the different purposes at industry levels, right? So in this particular case, so these are the chemistry that involves in synthesis and their properties, right? So here in this is the general preparation methods, right? So for preparation of the carbides, so depending on the nature of the raw materials or precursors materials, here this particular focuses with the help of metal oxide, or you can simply say that alkaline earth metals actually form oxide compounds. So they react with the presence of this carbon at high temperature. They will produce such type of structure, and through the release of this particular carbon monoxide gas. And if you have a metal carbonates means you here can see that react with the 4 carbon at high temperature, then such type of MC2 type of a structure also produce. So both reactions confirms that the methods that is used to synthesize particular carbides which contains C2 minus as a acetylide ion, and such type of compounds they are used to produce the acetylene gas, right? So next compounds, that is actually your this is that is Mg2C3, right? So another species that is C3,4 negative charge. This example clearly highlights the presence of C3,4 negative charge, that is another type of carbide species. So what happens, Mg2C3, right? So this is your magnesium carbide which contains 2 magnesium and 3 carbon species, 3 carbon centered anionic species, right? So here Mg contains 2 plus and C3 contains 4 minus, right? So this is your tetravalent anionic species, and this is your bivalent cationic species. Overall, the product of charges Z plus and Z minus is equal to 4 to the 8. So 8 times. So it has very high lattice energy. So high lattice energy compounds are actually such type of M2C3 type of ionic carbides. So it has very high lattice energy because of the product of charges here is 8 times. So U is actually directly proportional to the Z plus and Z minus. So it has 8 times compared to the another type of previously studies carbides. So they are most stable and they are very hard, tough because of the high electrostatic interaction between these two particular type of ionic species, that is bivalent cation, and this is your allylids. So this is called allylids because of the presence of 3 carbon center, and these 3 carbon centers as a result of the C triple bond C overall 3 negative charge, right? So this is your allylids, allylide. So this 3 carbon is actually is the combination of the bond, and it forms an anionic species that is called allylide ions. So because of the high lattice energy, such type of carbides are actually they are highly stable. So it requires actually high amount, a high volume of water for the hydrolysis. So it actually requires 4 volume of H2O, right? So once this particular type of carbides react with water, so it vigorously forms, that is magnesium hydroxide. So here 2 volume is obtained, and one another type of hydrocarbon, so that is unsaturated hydrocarbon, and that is called propane, right? So after the liberation of all the hydrogen atom from both end carbon centers, they followed such type of structure. This is called allylids, right? So this is the beauty of carbon, actually, that attains different type of anionic species through form carbide compounds. So this is the another way for the production of the different unsaturated hydrocarbons. So that is your propane, that is your gaseous state, right? So this is the beauty of actually nitrides and carbides. So both actually compounds, either nitrides or carbides, so they are actually used to produce gaseous products. So at a industry level or a commercial level, so that is why such type of chemistry are much more exciting, interesting, and also opens the pathway of the knowledge for further enhancement or development in a production or industrial processing, right? So this is actually the chemistry about that is nitride and carbide, right? So and most important, that is the application, as you have seen nowadays also, and today's whole environment or whole planet requires ripe fruits, right? So because of the demand of the large amount of, that is actually ripe fruits, so such type of carbides, that is artificial carbides, are used to ripen the fruits, right? So because you know that all the fruits that contains water in excess amount, right? So what happens, once the a layer of calcium carbide is casted over the fruits, then this calcium carbide actually absorbs water from the fruits, and they react to produce actually acetylene gas, and that acetylene gas help to ripe the fruits in a premature state also. So as actually it should be banned, and actually many of the countries, they have banned through the application of this particular carbides with reference to the ripening of the fruits, but actually demands are very large, so still they are actually used in process, and they are actually used by to ripening the fruits, and because of the acetylene gas that would help to ripe the fruits. So this is the actually chemistry behind the nitrides and carbides. So I hope all the chemistry, so that actually involves in the synthesis and processing of the nitrides and carbides, and actually what are the chemical and physical property of the carbides, so that will give you a better insights to understand the different types of ionic compounds actually. So that is actually they are industrially most important, and for the daily life also, in case of food and fruit technologies, actually they are interesting and they are used. But you know that most of the actually artificial carbides, they contain toxic traces of toxic metals, that is arsenic or phosphorus. So actually once they are used to ripen the fruits, they will enter into the core part of the particular fruits, and they will produce unhealthy. So actually because of presence of arsenic or phosphorus, it is unhealthy, and they will be carcinogenics, right? So the carcinogenic actually that is very dangerous for our body, and patient sometimes can die with excess use of this particular artificial compounds. So it depends on the extent or degree to which it is used for ripening the fruits. So this is the actually chemistry that is involved everywhere, so that you can think in a better way to understand the scenarios. So thank you, students, for listening, watching this particular video lecture, and I hope this video would be comfortable for your brain and for your knowledge to enhance the chemistry knowledge. So thank you. Again, I will meet you with another kind of video lecture, right? So